Hello everyone, welcome to my channel. In this video I have this integral to work on. It's the integral of the square root of 1 plus sine x dx. Now we're required to integrate this. Now how do we handle this? Well, we approach it from what we call conjugates as follows. So this is page 1, the integral of the square root of 1 plus sine x dx. Now, like I said, we work on the idea of conjugates. I'm going to have to multiply in the numerator by 1 minus sine x, and then in the denominator also. In other words, which transform this integral as follows. This is equal to the integral of the square root of 1 plus sine x, if you like, over 1, times the square root of 1 minus sine x all over the square root of 1 minus sine x dx. Now you can see that this is the special one right there. We haven't changed this integral at all, but I'm going to combine those two and then combine down here. You'll agree with me that what we have now is this must be the same as the integral of the square root of 1 plus sine x times the square root of 1 minus sine x, and we're saying we're dividing this by the square root of 1 minus sine x dx. Now in the numerator we have what we call conjugates. Now these two with square root there, it transforms as follows. The integral of the square root of, in brackets, 1 plus sine x 1 minus sine x, and we're dividing this by the square root of 1 minus sine x, and of course dx there. Right, now in the numerator, difference of two squares, that is the idea behind conjugates. You'll agree with me that this is just 1 squared minus sine squared of x. So we take this to page 2. Page 2, what we have now is the following. Page 2. So I'm saying that is the same as the integral of the square root of 1 squared minus sine squared of x, and we're dividing this by the square root of 1 minus sine x, and we're saying dx. Now let me explain something here. The idea behind conjugates is the following. If I am told from difference of two squares, a plus b and then a minus b, this is equal to a squared minus b squared, difference of two squares, these are what we call conjugates. So if you agree with me, if I have 1 plus sine of x times 1 minus sine of x, surely if you apply this one, you'll see that this just simplifies to 1 squared minus sine squared x, which is just 1 minus sine x, sine squared x, sine squared x, sorry about that, 1 minus sine squared x, like so. Right, now there's something else that I want you to see. What I want you to see is, we know that sine squared of x plus cos squared of x equals 1. So if I solve for cos squared of x, I'm going to get 1 minus sine squared of x. So this expression should be replaced by that expression. So now we're saying this is the same as the integral of the square root of 1, let me simplify it first, minus sine squared of x all over the square root of 1 minus sine x, and then dx. Now, like I said, in the numerator we have the integral of the square root of cos squared of x divided by square root of 1 minus sine x dx. Now you agree with me that this cancels that, and what do I have? The integral of cos of x all over the square root of 1 minus sine of x dx. This is what I have now. Alright, now I'm gonna use u substitution now taking us to page 3. So using u substitution on this expression here now in the denominator, if you agree with me, and we have a square root, so this is page 3. We are going to let u squared be equal to 1 minus sine x. Now, two equations to obtain from here. The first one is take positive square root on both sides. You get u equals square root of 1 minus sine x. And then the second equation is differentiate both sides implicitly. Derivative of u squared with respect to x is 2u du dx. On the right hand side, derivative of 1 is 0 is a constant. Derivative of minus sine is minus cosine of x. And then multiply by dx both sides. We have 2u du equals minus cos x dx. Multiply by minus 1 both sides. Minus 2u du equals cos of x dx. Why am I doing this? Because if you look at this integral here, we can transform it as follows. We say that integral is the same as the integral of 1 all over square root of 1 minus sine x times cosine of x dx. Now notice this part is that part. So I can replace this by that, and then down here I'm going to have square root of u squared, because 1 minus sine x is u squared, as you can see there. Taking us to page 4 to just complete this one off. So we're now saying this integral then changes as follows. Alright, so now we're saying that integral is equal to, and this is page 4. That integral is equal to the integral of 1 all over square root of u squared times minus 2u du. Remember, this equals minus 2u, as you can see there. Let me show you what I'm talking about. If you look at this one here is minus 2u du. So that should take the place of this one here. And then I'll have 1 over square root of u squared, because 1 minus sine x is equal to u squared, as you can see here. 1 minus sine x equals u squared. So this is what we have. Now du, don't forget that. And then now what do we have? Minus 2 is a constant, take it out. An integral of 1 over here, remember it's just u times u du. And these cancel. So what do we have? We have minus 2 times the integral of 1 du. And you'll agree with me that this is minus 2u. And we have to say plus c, because this integral is an indefinite one. But what is u? Well, we solved for u up here. U is just the square root of 1 minus sine x. So I'm going to have that replaced by square root of 1 minus sine x. So this is equal to minus 2 times square root of 1 minus sine x. And then we have plus c. Now, if you want to respect the format in which the question has come, which most lecturers will advise you to do, the format in which the question has come is this format here, 1 plus sine x, the square root of that. If you want to have your final solution containing that expression, we have to rationalize this expression. In other words, multiply by the conjugate of this in the numerator and in the denominator as follows. So you will have, otherwise this is just fine as a solution. But I'm saying you can also rewrite this as minus 2 times the square root of 1 minus sine x, and then multiply this by the square root of 1 plus sine x, remember, sine x, but you don't have to change this, so you divide by the square root of 1 plus sine x, and then plus c, simplifying this, so we just finish it off. This part here, we do the same trick we did earlier on, conjugates. So what we have finally is gonna be, and this is on page 5 now, page 5. What we have now finally is going to be the following. So we'll say this is equal to minus 2 times the square root of 1 in brackets minus sine x, and then 1 plus sine x, like so, and we're dividing this by square root of 1 plus sine x, and then what are we saying, plus c. Now simplifying the numerator there, you agree with me that this is minus 2 square root of 1 minus sine squared x all over square root of 1 plus sine x plus c. This is minus 2 square root of cos squared x all over square root of 1 plus sine x plus c, and then finally this cancels that, and what do you have? You have minus 2 cosine of x all over square root of 1 plus sine x and then plus c. This would be the final solution if you want your solution to contain the original expression, which is the original expression, that one under the square sign, as you can see in our original integral, the integral of 1 square root of 1 plus sine x dx. You have that expression in the denominator here, but in the numerator you have 2 cos x, and then again the whole expression there is negative. Don't forget that minus sign, and then plus c, the integral of the constant of integration c there. Of course, we know that c is a real number in this case. All right, I hope you found that useful. I'll see you in the next one.